Okay, so what I'm hearing from people is they're doing Pythagorean theorem. Can we do Pythagorean theorem with any triangle, or does it have to be a particular compass? Has to be a right angle. So this thing is a square, and we kept the diagonal. Do squares, what are all the angles in the corners of squares? 90. Is that a right angle? Yes. In Euclidean space, if we break that for right angle is, I don't know, 30 degrees, you're on a cone. If it's greater than 30 degrees, you're on a Pringles chip. So, sorry. That's college geometry coming out. So people said, I think I heard Trey saying, we would do Pythagorean theorem, which is length squared plus length squared equals hypotenuse squared. So h, in this case, is the square root of 2. Danny, how big is this angle if that one's 90? What'd you say?
45.
45. Anne Marie, how big is this angle?
45.
Why?
Because it has to add up to 180
Okay,
degrees.
the three angles have to add up to 180. What kind of triangle has, what do we call it when two sides are the same? Isosceles, right? Isosceles. And across from the equal sides are equal angles. So really, that one angle was 90, so we had 90 degrees left over, because Emery said they all add up to 180. We had 90 left over to share equally between those two corners. All right, so there's that one. The way that Mr. Carlos and I teach unit circle is we ask you to memorize that triangle. Because right now, Mache, what is sine of 45? Looking at the triangle, sine of 45? One over square root of 2. And, okay, if it's a standardized test, they're gonna ask you to multiply by 1. Won't you look in 1, but a 1 to get root 2 over 2? I don't care. If you leave it as 1 over root 2, I don't care. Jack, what do you think? What is tangent of 45? Looking at the triangle.
Is it 1?
1 over 1. Opposite over adjacent. 1 over 1 is 1. Yes. So here you're able to tell me unit circle things right now. Oh, goodness gracious. Secant is, which one? Secant is which upside down, cosine or sine?
No.
Cosine. Cosine. So, Trey, what is secant of 45? So cosine upside down.
Root 2 over 1.
Root 2 over 1, which I could also just call it root 2. Yes. So I know all those things, I know. I know sine, cosine, tangent, and their reciprocals for 45 degrees. Cool. Okay, this other triangle, it starts off being an equilateral triangle. What does equilateral mean, Maud? All the sides are equal. Danny, what do I know about all the angles in an equilateral triangle?
They should all be equal.
They should also all be equal. So know, how big is the corner of each angle in an equilateral? 60. So how big is that little piece right there, Cherry? It's 30. Because that piece is 30 and that piece is 30. And that little guy is 90. Okay. So Abraham, in just this half of the triangle, of that equilateral triangle, is that brown one not equilateral, is it a right triangle?
Yes.
Yes. So, Sophie, using Pythagorean theorem, what am I gonna set up?
Like, are you trying to find the hypotenuse?
We're trying to find h.
You're gonna set, you're gonna do the thing that's like side, or which sides do you?
Pythagorean theorem. A squared plus b squared equals c squared.
So
Tra-
using the 1 and the 2.
The 1 and the 2 and the h. So, is it,
One squared plus
Is it h squared or is it 2 squared?
2. H.
H. Because across from the 90 degrees is the one that's across the equal sign. Why did I write to the board? So 1 squared plus h squared is 2 squared. H is root 3. Okay. To pull that out more cleanly. 1, 2, not quite 3. Nava, looking at it. What is sine of 60?
Square root of 3 over 2.
Root 3 of 2. Hosea, what is cosecant of 60?
2 over square root
Is that guy upside down, or cosecant is hypotenuse over opposite. Alex, what is tangent of 30?
It's 1 over 3.
1 over root 3. Gotta say the square root. 1 over root 3. Amelia, is it making any sense? You're lying to me. Amelia, what is tangent of 60?
2 over 3.
Tangent is opposite over what?
Oh, sorry. 1 opposite. It's from 60.
From
up.
60
Root 3.
over 1.
So root 3.
Okay, all right. So just to tell you what's going on. Homework tonight is Delta Math, and if we don't finish everything, particularly this radiance thing, please look it up on Delta Math. Click the show video. Retakes are Friday and or Monday, depending on what you signed up for. You need to sign up in advance. You can't come in and say, so I changed my mind, I wanna redo this quiz that I haven't even looked at, and I'm gonna just like roll the dice and hopefully do better. No, you need to sign up for it in advance. You need to sign up by the end of class, or sorry, the end of school today, okay? If you don't sign up, you do not take a retake. Yes?
Did you say anything about giving back?
Yeah, I'll hand them back. So some of you turned in quiz corrections already, and I will hand them back to you. Yeah?
Can I sign up for a test today but give you the quiz corrections tomorrow?
Yes. Yes, so you can sign up today, but I need quiz corrections before the end of the week. Yeah?
Can I sign up after school today?
The thing closes at like 2:30. Why can you not do it at some time, like at lunch?
I'm meeting with the teacher at lunch. Maybe see if I can find time in another class. I'll figure it out, sure.
I mean, it doesn't take that long to click, like, I wanna retake this and retake that.
Sure, I'm sure I'll find an opportunity.
Yeah.
Will there be a review for the short quiz on pre-calc so far?
Okay, so there will be some quiz on whatever we get through in trig so far. The review is, we're doing it now,
Oh, gotcha.
okay? All right. If you guys don't have these 2 triangles drawn as written, please draw them. And sorry, these square roots got clipped, but using them, can you figure out what x and y are in the 2 triangles below? shrink works is that when you shrink or stretch a triangle that keeps these angles, they will be proportional to each other. That was a geometry thing, similar triangles. So if this is 45, 45, 90, and this is 3 and 3, this hypotenuse is gonna be 3 times the square root of 2. If this side is 35, 35, that hypotenuse is 35 root 2. They are proportional. So, this triangle, if I match the sides up correctly, leg to leg equals hypotenuse to hypotenuse, or across from 45 compared to the other guys across from 45, and 9 across from 90 to across from 90, it will be equal. So, Fernando, in this first triangle, X or Y, which one do you wanna solve for first?
X.
X.
Or
Okay.
It's gonna be the same.
Yes, or Y? Okay, so he just said X and Y are gonna be the same. Manuel, do you agree with that? Good, cause it's true. Can you tell me why? No. Ciela, can you tell me why? So, isosceles triangles, the angles that are equal, the sides across from them will be equal. So, good point, if we solve for X, we are also solving for Y, because they're gonna be the same. So Valentina, across from X, X is across from which angle? 45. So Abraham, I'm gonna go to this triangle that we're supposed to have memorized, or we're gonna get memorized. What's across from 45 in this triangle up here?
Also 45.
Across from 45 was 1.
I have a question about that triangle that we're supposed to have
Yeah.
next time. Is it always gonna be the square root of the side plus the side?
Side squared plus side squared, yes.
So like 1 plus 1 is 2, is that just for if it's 1 and 1, or is that always?
So, in this triangle, it was a square cut in half, right? So this length and that length will have to be the same, because it was a square. So a squared plus a squared equals the hypotenuse squared, because that's the way Pythagorean theorem works. So if I do the square root of 2 times the square root of a squared is a. So like I just said,
Just if it's 1.
well, this length was 35, that hypotenuse is whatever the side length was, times root 2.
So it's just if it's 1, thank you.
Okay. Emilio, in this triangle here, what is the one length that I know?
1.
Which is the hypotenuse, or, sorry, an across from 45 or an across from 90?
What angle are we trying to find?
We're not, we're trying to find X or Y, we're finding a side length, but this one, I need to figure out which side it's gonna compare to up here. So this one is across from what angle?
90.
The 90. So across from 90, and I need to compare it to the across from 90 in the template that we've got memorized. What is the across from 90 up here? What is the length?
Oh, sorry, root 2.
Root 2. So what is the X value? If this length is 1, the X value is 1 over root 2. What is the Y value? Fernando already told us it's gonna be the same. It is also 1 over root 2. Emma, if I said, I was a pain and I was like, I don't want square roots. How do I get the square root out of the denominator?
Or you
Multiply by 1. What's the 1 gonna look like? Multiply by root 2 over root 2. Jack, is square root of 2 over square root of 2 equal to 1? No? Brianna? That's 1? Okay. I'm allowed to multiply by 1. It's a weird looking 1, but it's 1. For those of you who don't remember square roots, outside times outside, so there's nothing written out here, so 1 times 1, and then inside times inside, well, it is just root 2. Inside times inside, leave it inside. However, square root of 4 is 2. So if they want this rationalized, 1 over the square root of 2 is root 2 over 2. Martha?
I solved saying sine of 45.
Okay.
Is that okay?
Yep.
Do I have to-
If you know what that is, that's fine. I'm trying to get you guys to see how these, where they come from. So if you guys already know what sine, cosine, and tangent are of 30 and 60 and 90, cool. Okay, across from 30 is what? Across from 30, like I'm trying to show you how we're gonna solve for unit circle in this class. Across from 30 in the triangle I was given is y. Across from 30 in the triangle I have memorized is 1. Across from 90 in the triangle I was given is a 1. Across from the 90 in the triangle I have memorized is 2. Y over 1 is just y. That's a half. And some of you already know what sine of 60 is, some of you don't. So how are we gonna find out what is x across from 60 versus the thing I've memorized across from 60 equals 1 I was given across from 90 and across from 90 yes,
Why are you using the angle, the like number across from 90?
because it's in that triangle on the bottom right in red, it's the only number I know. I have an x and a y and a 1. I need to use the number that, I need to use 1. The number that I'm given versus the other unknowns. I'm trying to figure out the unknowns. Versus, this is unit circle, the hypotenuse is 1. If I stretched it and I made it 10 units long, okay, that means, it's 10 times bigger everywhere. So Alistair, what's the question? Sounds like you guys are having good math questions.
No, it's not even.
Okay.
You already answered it, but.
Okay. Eleanor?
Why is it x over square root 3?
Okay. Y is at x over square root of 3. Okay. The triangle that I want to figure things out, I have across from 60 is a thing I don't know. So I'm going to compare it to what's across from 60 in the template that I've just created by cutting an equilateral triangle in half. That guy's across from 60. And then the one side that I know in this triangle down here, Fernando says the one that I know down here is that hypotenuse. I need to compare it to the hypotenuse here. And then multiply both sides by that square root of 3, basically cross multiply. Really what the point of this is, if you guys know that triangle, you should be able to answer all of these questions. Conchetta, looking at it, sine of 45 degrees. There's 45, sine is opposite over hypotenuse. So what is, using the side legs that we have memorized, 1 over root 2, which I am fine with it stays that, if it is left that way. Please realize they might write it like that. You need to know that 1 over root 2 is exactly the same as the square root of 2 over 2. Valentina, what is cosine of 45? 1 over root 2. Brianna, what is tangent of 45?
1 over 1.
1 over 1, so I could just say 1. Kira, what is cosecant of 45?
That would be root 2 over 1.
Root 2/1, I'm only gonna write root 2. Ahmed, is that okay? Yeah, okay. So Ahmed, what is secant of 45? Square root of 2. And I'm not gonna be this nice all the time of being like, oh, these guys are the upside downs of each other, just look next door and turn it upside down. Cotangent of 45 is 1 upside down, which is still 1. Or you could look at this and say cotangent is adjacent over opposite, 1/1. I do them all by looking at the triangle rather than looking at the other dudes. But this is the beginning of unit circle. And you guys are gonna have to use this information to be able to say, okay, because I know these, I can tell you what sine of 145 or 135 is. And I can tell you what sine of 210 is. And sine of 300. You'll be able to figure those all out if you know this one triangle. Well, 2 triangles. Let me show you the other one. The other one we created. Does anybody have it written down? Hosea, wake up.
One, there's square root of 3, and then 2.
Okay, so you need to know those. Jack, the smallest side, is the smallest side always across from the smallest angle, the medium angle, the biggest angle, or is it random?
Smallest thing.
It is always across from the smallest angle. So if you know the numbers 1, 2, and it's not quite 3. Is square root of 3 bigger than 2 or less than 2? Less than 2. Think about it this way, square root of 1, square root of 3, square root of 4. Square root of 1 is 1, then square root of 3, and then square root of 4, which is 2. So the smallest side is across from the smallest angle. 60 is smaller than 90, so the next smallest is the root 3, and the biggest is 2. So what's sine of 30? 1/2. Rakib, what is cosine of 30? Cosine, so cotilla, adjacent over hypotenuse. So looking at the 30, what is the adjacent? Okay, adjacent means next to, so it's the one that is not the hypotenuse. The root 3/2. Emery, what is tangent of 30?
1/3.
1/3. So then, Cherry, cosecant of 30? 2/1 or just 2. So basically it's secant of 30, this guy upside down. 2/3. And cotangent of 30 is root 3. Okay, Abraham, ready?
Yeah.
Looking at the triangle, sine of 60. So here's 60.
So it's, the square root of 3 over, so it's just that. Cause it's next to
Over
adjacent, which is
hypotenuse.
1.
So
Oh, you're right,
come-
you're so right, you're so over 2.
Over 2, there you go. So now that you've got that, what is cosecant of 60?
2 over the square root of 3.
So guys, it's super duper big deal. You need to be able to draw the triangle correctly, and you need to be able to spell SOHCAHTOA correctly. Because if you get any one of them wrong, you get everything wrong. Cosine of 60, cosine is adjacent over hypotenuse, that's 1/2. So secant is that upside down, which is 2. Tangent of 60, root 3/1.
I don't trust, I usually know SOHCAHTOA, I just have it written down, the pressure.
I got you. All right, I need to show you this at least. Do any of you know what radians are? What is a radian? What? It is. Ooh. So. It's completely random. Subtended. Take that length of. How many radiuses wrap all the way around a circle? Six, let's see, 1, 2, 3, and a little bit. What is that little bit?
Pi.
Yeah, so if you go half a circle, it's 3.14159, blah, 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 blah. So all the way around the circle is 1, 2, 3, 4, 5, 6 radians, and this little smidgen, 0.28, blah, blah, blah. Okay, how many radians, how many radiuses go halfway around a circle? Pi. How many radians go halfway around a circle? Pi over 2. So 90 degrees equals pi over 2. Oh. How many radiuses did that go around?
4.
So how many radians is that angle? 4.
Good job.
About 30 points, that's a lot. Really good.
Spectacular. All right. So guys, part of what your homework is converting radians to degrees on Delta Math. Look at it.